All right, algebra, back at it. Section 6.5, applying systems of linear equations. So we got two things on the objective today. One of them is to determine the best method to solve a system, right here. And then the second one would be to solve word problems. So the first part of that is finding the best method to solve. Remember, we've come up with a bunch of different ones: graphing, substitution, and elimination. Both elimination with addition and then elimination with multiplication. And then determining what's the best time to use those. When's the best time? And then taking those and applying them to word problems. So let's take a look at it first with graphing. So when you're graphing, probably the best time to use when you're graphing is if the equations are in y equals mx plus b form, because it's easier to graph that way. If they're in standard form, you're probably going to use a different strategy rather than turn it into y equals mx plus b form to graph it, because graphing is not the most fun. The other time is if you're asked to graph it, if I tell you to graph it, or if on a test or a quiz it says graph these. And then if you only need an estimate of the solutions, maybe a quick sketch and say, hey, it's in quadrant 1, both of them are positive, something like that. If you just need a quick estimate and not an exact solution, maybe graphing a quick graph would be the best. How about substitution? Substitution, we want to talk about if one variable has a coefficient of 1. One variable has a coefficient of 1. So if we already have it in a situation of x equals something, or if there's already one that just has a coefficient of 1. So for example, if we had like 2x plus y, the y value here has a coefficient of 1, say it equals 7. The y value has a coefficient of 1, so it would be easily solved for, that's the second part. If one equation is already solved, if it already was in y equals form. But if it has a coefficient of 1, it's easy to solve, because all we would have to do here is subtract 2x from each side, and then you'd have y equals 7 minus 2x. Okay, so then it was, the coefficient of 1 made it easy to solve. Or if the second case here, if it's already been solved, if it's already in this form, y equals or x equals, then it's easy just to substitute it in. How about elimination? Well, elimination, they broke into two separate sections. One, just regular elimination with just addition. And in this case, we want to do it if you have a common coefficient. Common coefficient. And just remember with this one, we want the equations to be in standard form. If they're in standard form and everything's lined up, your x's, your y's, and your constants, then it becomes pretty easy to use elimination, especially if you have a common coefficient. We can just add or subtract. You may have to, get the negative, multiply by a -1 to get one of them to be an opposite sign. And then finally, elimination with multiplication. Remember, these kind of are very similar, but elimination with multiplication, this is one if none of the coefficients equal 1 and neither variable can be easily eliminated. Then you can have to multiply each equation to try and see if you can get some to cancel out or eliminate. And that's kind of last resort. And I like that one. Once you figure that one out, you can kind of always use it if they're in standard form again. But that one just something to think about. If none of the other ones work really easy, then you can always use elimination with multiplication. Okay, let's take a look at our second objective with solving word problems. So what we want to do is, the first thing we're going to try to do is every word problem we're going to have to find two variables in there, whether it's an x or a y, or maybe you label them something different, p and q, whatever it is. But you're going to have to choose two variables, and then we're going to write a system of equations. So we're going to write two equations and read it carefully and look for the key words that tell you how we're going to set this up. And then third thing we can do, we can solve using any of those methods. You can graph it, you can substitute, you can use elimination. Try to figure out the best method, the one that's going to be easiest and fastest for you. And then our final answer should be written as an ordered pair, as it has been for the entire chapter. Okay? All right, so let's do some practice problems, and then we'll get rolling. So this one, it says determine the best method to solve this system, and then write your answer in as an ordered pair. We're just going to do the first part of this one. Let's just determine the best method, and then kind of talk about it, and we won't have to solve it because we're going to solve some later on here. But if I'm looking at this one, they're in standard form, so I'm going to look first and think elimination. Because it's in standard form, and you can see that my x's are lined up, my y's are lined up, and my x's are lined up, my y's are lined up, and my constants are lined up. So I'm going to look at using elimination. I would probably have to multiply this bottom one by 4. I use multiplication, multiply this whole thing by a 4, probably a negative 4 too, because I want to get rid of the x's. But that would be your choice on what you wanted to do. The other thing you could do, and so I'll just write that one down, you're going to kind of want to multiply the second equation by a negative 4. And that would kind of get you to eliminate your x's if you wanted to eliminate x there. And I would look at doing that one because it would be pretty easy just to multiply only one of the equations. If you try the y's, you're probably going to have to multiply both of them. The other thing you could use, and some of you might have said, hey, substitution. Substitution. Because if you look here, we've got an x value with a coefficient of 1. So it would be really easy to say, if I subtract that 2y, it would be x equals negative 2y plus 14. And then I could go ahead and take this and sub it into this x if I wanted to for the first equation, if I wanted to use substitution instead. So no real wrong answer there in what you chose. And you could actually put them both into slope-intercept form and graph them if that's what you wanted to, but I think elimination and substitution would be easier on that one. So that's how we would get started. Choose the best method and then solve. We're not going to solve it because we'll solve some other ones here and then get some practice doing that. How about this one? In this case here, this one kind of screams substitution to me just because of the second equation. And because that second equation is already in the form y equals something, y equals x. So if we look at that second equation, it'd be pretty easy just to use substitution and say, hey, here's my x, so I'm going to sub that in for every y I see because y equals x. So that would be the easiest way, I think, the fastest way. If you wanted to use elimination, you could also use elimination as a second option. And in this case, you would have to get it back into standard form. So your first equation would look like this. It would look the same because it's already in standard form. And then your second equation, you just have to bring that x over and subtract x from each side. So you'd have like a negative x plus y equals 0. And then you could use elimination, but you'd have to get it in standard form. And now, in this case, you'd still, with these two equations, still have to multiply by something to do that. So I think substitution would be the fastest way on that one. All right, now let's actually solve a couple of these here with the word problems. So in this one, number 3, Zach. Zach has volunteered 50 hours and plans to volunteer 3 hours a week in the coming weeks. Allie is a new volunteer, hasn't volunteered at all, and she plans to volunteer 5 hours a week. And write and solve a system equation to find how long it'll be until they have volunteered the same number of hours. So this one's a little bit tricky because it's going to be different than the system equations we've had. So if we take a look, just got to read carefully. That's why it says on this step back here to right here, write two equations and read carefully. Look for the key words because this one has some keywords that will help us out to make this not as difficult. So if we use some variables, that's our first thing. We're going to use, say, Z for Zach. And then let's use A for Allie. Okay? For Zach, we're looking at, he's already volunteered for 50 hours. He's already done 50. And now he's going to go 3 hours per week in the next coming weeks. And then Allie has not volunteered at all. She's a new volunteer, so hers would be a 0 to start here. But then she's going to go 5 hours a week, 5W. Now the key words here are how long will it be until they have volunteered the same number of hours. So same being a key word to say we want them to be equal. So eventually we want our answer to be z equals a, somewhere in there. So I could actually take those and say, hey, I'm going to substitute this in for my z, and I'm going to substitute this in for my a, and just set them equal to each other, because that would be easier to do. So if I go 50 plus 3w, that's Zach's volunteering, and we want to set it equal to Allie's, which is 0 plus 5w, and then we want to see where they would be equal. And so now it's just doing the algebra, and saying, okay, well, I'm going to subtract 3w here, and then I'm going to end up with 50 on the left here. Those 3w's are gone, so equals, 0's gone, 2w. And then I just have to divide by 2, and then w equals 25. And so what that would mean would be w is in weeks, right? That's what we're talking about. We're talking about weeks, so that would be our w's. And it was tricky because we kind of had three variables. We had a z, an a, and a w here. We don't like 3w's. That's why we got to look, or we don't like three variables. That's why we got to look for those key phrases here to say, hey, we could set those equal to each other. And then we're only dealing with the w's. So this would mean 25 weeks. So w is 25 weeks it would take for them to volunteer the same amount of time. Because if you think about it, Zach's already had the 50 hours in. But he's going to do less volunteering from here on out. Allie hasn't volunteered, but she's going to work more. She's going to do some more volunteering per week. So it's going to take 25 weeks for them to equal up. Okay? Let's do another one where it's actually a system of equations here. So hot dogs and pops. So we've got, it costs $5.25 to buy 3 hot dogs and 2 pops, $6.25 to purchase 5 pops and 2 hot dogs. Write and solve the system of equations. So we're dealing simply with hot dogs, H, and then pops will be P, okay, H and P. So if we think about the first phrase here, it costs $5.25 to buy 3 hot dogs and 2 pops. So we can simply go, it's going to cost $5.25, and that's if we buy 3 H, 3 hot dogs, and 2 pops. And then the second phrase here says, well, it costs $6.25. So if I go $6.25 for 5 pops and 2 hot dogs. Those are our equations. So we've already set up and we've got our equations. But something to think about is to what's the best method here? Graphing, elimination, substitution. I think it's going to be elimination. But I also want to point out that these are not lined up. So we want to get them lined up into standard form. As you can see, my H's and my P's are not the same. So I'm just going to take that first equation here, substitute it down here, and I'm going to rewrite it into standard form where I'm going to put my H and my 2 P's here, and then equal it to 525. I just like my number, my constants over on the right-hand side. And then the second one, we're just going to I'm just going to move it down here as well to make sure it's all lined up. So I'm going to go 2H plus 5P equals 625. So now I've got my H's and my P's all lined up and my constants all lined up. So now it becomes a little bit easier to say, okay, what am I going to do? If I go ahead and try to multiply, I think elimination by multiplication is the easiest, but which one do we want to do? We want to go with our H's or our P's here. What do we want to eliminate? Well, if we take a look at our H's here, if we were to multiply, what's the common factor would be 6, right? And then if we went ahead and said, well, what's the common factor with our H's and P's, or rather our P's, 2 and 5, the common factor would be 10 here. So I'm going to go with the H's just because I think that would be, I'll move that out of the way for us, a little bit easier to work with. So to do that, I'm going to multiply the top one, and I'm going to get these out of the way for us a little bit too. Just, oh, I can't do that. Never mind. I'll erase it. Just so we're cleaned up a little bit. So I want to get the 6. So what I'm going to do here, like I mentioned, let's kind of get rid of that. And write that back. Okay, so if I want to get to that 6, remember that's the key, is to get to a 6 up here. To do that, I'm going to have to multiply the top equation by 2 because 2 times 3 equals 6. And then the bottom equation I'd have to multiply by 3, but I'd also have to multiply it by a negative 3 because I want them to be opposite signs so that we could eliminate them. So let's go ahead and do that. The top equation, 2 times 3h would be 6h. 2 times 2p is 4p. And over here, don't forget to multiply here. We get 1050. So 525 times 2. And then the second equation, we're multiplying by a negative 3 now. So negative 3 times 2h is negative 6h. 5p and negative 3 is a negative 15p. And then we've got a negative 1875, if I check my math correctly there, negative 1875. All right. So now I can go ahead and add and eliminate here. We can see that our h's are going to cancel out. And now over here I'm going to have negative 11p. And when I do this math here, I think you come out to a positive 825. Or no, excuse me, negative 825. And then we know that we just have to divide here by 11, or negative 11. And then to just check my math with the decimals here, it looks like p is going to be equal to, a negative and a negative make a positive, and I think it comes out to 75.75. So that'd be 75 cents. 75 cents for a pop. Okay, so now I'm not quite done. I can go ahead and sub it into any of these equations, and I'm going to just use that first one, 3h plus 2p equals 525. So 3h plus 2p equals 5.25. And remember now I'm going to substitute 0.75 in for my p, because it's 75 cents for a pop. So now it's going to be 3h plus 2 times 0.75 is actually 150 equals 525. Then I can go ahead and subtract 150 from each side. And I end up with 3h equals 375. And when I divide by 3, my hot dogs are worth $1.25 each, 1.25. Okay, so then we got to put it in ordered pair, and so we're basically going to say for my answer, final answer, ordered pair, I'm going to have my hot dogs and then pops. So $1.25, comma 0.75 would be my final answer here. Decimals are not the easiest to work with, but when you think about it in terms of money, it's actually pretty nice, $1.25 and 75 cents. Okay. Let's try one more here, just because we see these numbers quite a bit here. The sum of two numbers is 70. One number is 10 more than twice the other number, so find the numbers. So when we first, again, picking out two variables, we're going to say x is our first number, and then we're going to say our y is our second number. Okay, so that makes it easy. We got our two variables. Now let's write the equations. The sum of two numbers is 70. Well, we know sum means add. We got our x and y here for our two numbers, and we got an equal sign for is 70. So that first equation should be just simply x plus y equals 70. And we've done an example like this a couple sections ago. And then the next one, but it was a little bit easier than this one. The next one says one number is 10 more than twice the other number. So we've got an is there, so we know we're going to have another equal sign. And it says one number is 10 more than twice the other one. So if we say one number, x, is equal to 10 more than, means 10 plus. 10 more than, add 10. And then twice the other one would be our 2y. So it'd be 10 plus 2y here. So now I'm in a situation where maybe it's not elimination that we use. Maybe it's substitution because I've already got it in the form of x equals. So that's what I'm going to do. I'm going to take this 10 plus 2y and sub it into my x, because that's what it says x is equal to. So then I could just use substitution to say, well, 10 plus 2y plus y equals 70. And Now I'm going to combine these like terms. I've got a 2y and a 1y. So that would make a 3y. So 10 plus 3y equals 70. And then I subtract my 10. And 3y is equal to 60. So then y, after I divide, is equal to 20. So I know y is equal to 20. Then I can plug it into any of these, either of the two equations. I'm going to choose that first one and say, well, x plus y equals 70. And since I know I'm substituting in 20 for my y value, it'd be x plus 20 equals 70. So I know that x is going to be 50 here. And so that would be my final answer, 50 and 20. Again, we want to write it like an ordered pair. So it'd be 50, comma, 20 would be my final answer. Okay, let's skip this one. Takes us to the lesson summary. What are your steps in solving a word problem that involves a system? That should be taken right from your notes. And then we've got this one that I don't ever actually want you to solve it. You can if you want, but just write a system for this situation. James bought 4 t-shirts and 3 pairs of jeans for $181. Sarah bought 1 t-shirt and 2 pairs of jeans for $94. T-shirts were all the same price. Jeans were all the same price. Write a system for the situation. You don't have to solve it. If you wanted to, go ahead and solve it. But you don't have to. You just have to write the equations up and put them in that pair. All right. I know there's kind of a long one here, but that does it. We covered a lot of ground with section 6.5. We'll bring your questions. We'll see you tomorrow.